Hello and welcome to Math Age. Today we want to look at a question on differentiation. This question appeared in Sterling Bank Maths quiz competition. The question says differentiate the function y is equal to cube root of x squared bracket 2x minus x squared. I've always maintained that competition students don't just jump into questions without asking what hidden mathematics is the examiner testing me on. So here the examiner is testing whether you know when to avoid the product rule in differentiation. Although the function initially appears to be a product, expanding it first turns it into simple power functions. This lets you apply the power rule directly, making the solution shorter, faster, and less prone to mistakes. And that's a classic Olympiad strategy. The first step in solving this question is to rewrite the whole expression using indices. And from the fractional exponent law of indices, we know that when a number is raised to the power of a fraction, the numerator of the fraction becomes the real power while the denominator becomes the root. That is to say that if a is raised to the power m over n, it is equivalent to the nth root of a to the power m. So when we have the cube root of x squared, it is the same as x to the power 2 over 3. And from that, the whole expression becomes y is equal to x to the power 2 over 3 bracket 2x minus x squared. So you see that we have rewritten their expression using indices. Y equal to x to the power 2 over 3 bracket 2x minus x squared. Now the next thing is to expand the expression. Please note that here the temptation in this question or the trap is to attempt using product rule, which though will give a correct answer, but will subject the student to possible errors and time wastage. The hidden trick is to express y equal to x to the power 2 over 3 multiplied by 2x minus x to the power 2 over 3 multiplied by x squared. That is multiplying everything in the bracket with what we have outside the bracket, normal expansion. In expanding the expression, we still apply the law of indices. Recall that when two indices on the same base are multiplied, we retain the base and add their powers. That is to say that x to the power a multiplied by x to the power b is equal to x to the power a plus b. We add their powers a and b and retain the base x. So from here, when we expand the expression above, we'll get 2x to the power 2 over 3 plus 1 minus x to the power 2 over 3 plus 2. Therefore, y is equal to 2x to the power 5 over 3 minus x to the power 8 over 3. That is the function we are going to differentiate now. Before I go ahead, I want to take it for granted that you know that 2 over 3 plus 1 is equal to 5 over 3, while 2 over 3 plus 2 is equal to 8 over 3. I want to take that for granted. However, if you don't know how we got it, try it out, adding them up. Let's go ahead. We are going to recall and use the power rule, which is the most common rule in differentiation. The power rule says that if y is equal to x to the power n, the y dx will be equal to nx to the power n minus 1. Put the other way, when we differentiate a function x to the power n, the power multiplies the coefficient and reduces by 1. I take it again. The power multiplies the coefficient and reduces by 1. If the power is n, as we have y is equal to x to the power n, when you differentiate with respect to x, you discover that the power of x, which is n, multiplies the coefficient of n, in this case it is 1, and reduces by 1, that is n minus 1. That's how we got nx to the power n minus 1. Remember that we say in step 3, we differentiate term by term. So in differentiating term by term, we first of all differentiate the first term, which is 2x to the power 5 over 3. And this will give us 2 bracket 5 over 3 x to the power 5 over 3 minus 1. See what we've done here? the power of x, which is 5 over 3, multiplies the coefficient of x, which is 2, and reduces by 1, which is 5 over 3 minus 1. And this will give us 10 over 3 x to the power 2 over 3. We differentiate the next term, which is minus x to the power 8 over 3. Just the same way, 8 over 3, which is the power, multiplies the coefficient of x, which is 1, and reduces by 1. That is minus 8 over 3x to the power 8 over 3 minus 1. And that gives us minus 8 over 3x to the power 5 over 3. So the final answer is that dy dx is equal to 10x to the power 2 over 3 all over 3 minus 8x to the power 5 over 3 all over 3. And that gives us option B. A recap of the solution to this question. The first step is to rewrite the whole expression using indices to remove the square root sign and make the question less complex. The next step is to expand the expression to avoid using the product rule, which could be more confusing and time consuming. After you have expanded, the next step is to differentiate the expression term by term. And the whole thing looks so simple, and in a very short time, you've gotten the answer. If you have a question or a comment or a request, you can send it in the comment section. I hope to do more videos on differentiation and integration. But meanwhile, don't forget to like this video, share it to your classmates and co-students, and subscribe to our channel so that each time we make a new video, you will get a notification. So thank you and God bless you.